All right, welcome to The Explainer. Today, we're going to tackle a concept that honestly challenges how we see everything, from the universe itself all the way down to our own societies. It's called the Tetrachron Principle, and believe it or not, it gives us a surprisingly simple way to wrap our heads around the fourth dimension. So let's just jump right in with a big one. How can you picture a fourth dimension? I mean, this is a question that's stumped thinkers for centuries, right? It's a huge hurdle in modern physics. But what if the answer isn't about trying to imagine something totally alien? What if it's about looking at the world we already know, but from a completely different angle? Our brains are just wired for 3D. Length, width, height. It's how we move around, how we build things, how we live. But what if there's more? What if there's a simple mental trick, a shift in perspective that could finally give us a real, intuitive feel for that fourth dimension? Okay, so how do we actually do this? How do we build this new way of seeing? Well, this is where we get into the Tetrachron Principle, and I want you to do me a favor for a sec. Just forget all the complicated, mind-bending geometry stuff you might have heard. We're going to start with something surprisingly simple. So here's the core idea, and it's actually pretty elegant. The Tetrachron Principle says that any four-dimensional object, let's call it a tetrachron, is basically just a continuous stock of three-dimensional cross-sections. Think of them as slices. It's a powerful mental shortcut, a way to visualize what feels totally impossible. And this is the analogy that really makes it click. Look, just think about it for a second. You take a bunch of flat 2D sheets of paper, right? You stack them up. What do you get? A 3D object, a book. Well, the Tetrachron Principle just kicks that idea up one level. Now, imagine stacking entire 3D spaces, like snapshots of reality, one after another. If you could do that, you'd be building a 4D object. Now, it's super important to get this. We're not talking about some new, unproven law of physics here. This is a tool. It's a way to build intuition, a teaching aid. Back in the 17th century, a guy named Cavaliere came up with a principle that helped us understand 3D volumes by slicing them into 2D areas. The Tetrachron is kind of doing the same thing for the fourth dimension. It's making the abstract feel real and tangible. Okay, but you might be thinking, is this just a neat little thought experiment, or does it actually connect to, real science? And the answer is yes, absolutely. It turns out this whole idea of slicing up reality has some pretty serious relatives in the world of theoretical physics. This isn't just an idea floating in a vacuum. And this is where it gets really cool, because the Tetrachron isn't some lonely out there idea. It actually echoes some major concepts in physics. Take the ADM formalism, for instance. I mean, this is a cornerstone of Einstein's theory of general relativity, and it literally describes space-time as a stack of 3D slices that evolve through time. Sounds familiar, right? Or how about emergence theory, which hints that our 3D world might just be a projection, like a shadow, from a higher dimensional reality? The Tetrachron gives us a simple, intuitive way to start wrapping our minds around these super advanced ideas. But we have to be clear about the difference here. The ADM formalism, that's the real deal, a full-blown physical theory that describes our complex, curved, dynamic universe. The Tetrachron Principle, think of it as its simplified Euclidean cousin. It purposefully ignores all the complex physics of gravity and space-time curvature to focus on just one thing, the simple, intuitive geometry of stacking. It makes the core concept so much easier to get. And this quote just hits the nail on the head. It's a bit like Feynman diagrams in particle physics. Those little stick figure drawings aren't what particle collisions actually look like. They're fruitfully false. Their incredible power comes from how they help us organize our thoughts and gain insight, not from being a literal picture of reality. The Tetrachron is exactly like that. It's a tool for understanding. Okay, so now that we've got that foundation, let's have some fun. Let's see where this idea can really take us. Because once you have a tool for building a fourth dimension, you can start to construct some truly wild and beautiful things inside it, pushing into realms of infinite complexity and even art. Okay, remember that stacking idea? Good. Now, what if each new 3D slice you add is a slightly smaller copy of the one before it? And maybe you rotate it a little bit, too. And you just keep doing that over and over forever. You're not just building a 4D block anymore. No way. You're generating a 4D fractal, an object with mind-boggling complexity, with infinite detail nested inside itself. And this idea has totally become a playground for creative thinkers. It's inspired these really cool speculative concepts like the Adelic Voxel, some kind of hypothetical unit of information, and these incredible artistic models of fractal helicoids. Now, look, this isn't established science, but it's a perfect example of how powerful the principle is as a creative toolkit for artists, for sci-fi writers, for anyone building new worlds. All right, let's pull this right out of the cosmos and bring it down to Earth, down to our own towns and cities. This is where, for me, this idea gets really, really powerful. How can a concept for picturing the fourth dimension help us model something as messy and real as a city? Well, here's how. In this model, the fourth dimension isn't a physical one. Instead, it represents societal change over time. So imagine each slice is a snapshot of a city, say Daragazi Khan. And this isn't just a map. This slice is a rich 3D data model that encodes things like literacy rates, access to clean water, even metrics for social trust. And when you stack those slices year after year, you create what's called a social tetrachron. You can literally see the city's evolution. And this is not just some abstract idea either. It's grounded in real hard data. Just look at the urban growth of Daragazi Khan. It went from under 10 square kilometers in 1991 to over 27 by 2021. That's a massive physical change, and it's just one of many data layers we can bake into these evolving slices to see how the city is really changing. And this all leads to a really powerful metaphor, doesn't it? Society becomes a tetrachron of nows. We are all collectively building our future by stacking these nows. Every choice we make, every policy we enact, every action we take. It suggests our future isn't something that just happens to us. It's a structure that we are actively, consciously building, one slice at a time. So let's pull all these threads together. We've gone from theoretical physics to fractal art to urban planning. What's the final takeaway? What's the real value of the Tetrachron Principle? It's not just about any one of those things. It's about how they connect. Yeah, when you boil it all down, the tetrachron isn't really a theory you're trying to prove or disprove. It's what you'd call a framework for coherence. It's a lens. It's a way of seeing the hidden connections between physics, mathematics, art, and even social progress. It helps us see the world not as a bunch of separate pieces, but as an interconnected whole. Really, its success is all about how useful it is. Does it make really complex ideas easier to get your head around? For sure. It reduces that cognitive load. Does it spark new ways of thinking? Absolutely, we've seen that from fractal art to social modeling. It's a bridge, connecting fields that seem worlds apart. And so, that leaves us with a pretty deep final thought. If we run with this metaphor, if our reality really is a stack of moments that we're all building together, it forces us to ask a really important question. What exactly are we building with the slices we add day in and day out?